Good morning, students. Today I would like to discuss about the term Bohr Magneton. First of all, we will discuss today about the derivation of the expression of Bohr Magneton, and then we will discuss about the definition of Bohr Magneton, and then we will calculate its value and its unit. So, let us see the discussion. From Bohr's quantum condition, we can write mvr equal to nh by 2 pi. This is second postulate of Niels Bohr on hydrogen atom. This is second postulate, and this is also known as Bohr's quantum condition. It is mvr equal to nh by 2 pi. That is angular momentum of an electron is n times h by 2 pi, where n is the principal quantum number, that is number of orbit, and h by 2 pi is a constant, and h is known as Planck's constant, and mvr is the angular momentum of an electron at nth orbit, which is moving around the nucleus of hydrogen atom, and m is the mass of the electron, and v is the velocity of the electron, and r is the radius of nth orbit. So, this is second postulate of Niels Bohr on hydrogen atom, and this equation also known as Bohr's quantum condition. Here this equation we denote as equation 1, and let us see the next. Now, magnetic dipole moment of an electron in hydrogen atom is given by m equal to EVR by 2, where E is the charge of an electron, V is the velocity of that electron which is moving around the nucleus, and the radius of the path of the electron is r. So, an electron moving around the nucleus whose radius is r, and the magnetic dipole moment of that electron is m equal to EVR by 2. We can calculate it in different problem. Now, if we multiply m with numerator and denominator of this equation, of the right side of this equation, then we can write E by 2m times mvr. And in next step we can easily write, in place of mvr we can write nh by 2 pi, because of, according to Bohr's quantum condition, mvr equal to nh by 2 pi, and that is why we can write, in place of mvr we can write nh by 2 pi. Using equation 1 we can write E by 2m times nh by 2 pi, because of, in place of mvr we can write nh by 2 pi. And in next step we can easily write this small m, this small n times eh by 4 pi m, and this equation capital M equal to small n times eh by 4 pi small m, this equation gives us the magnetic dipole moment of an electron at nth orbit. So, this gives us the magnetic dipole moment of an electron at nth orbit. Now if we put n equal to 1, then the equation will become m equal to EH by 4 pi m. So if we use n equal to 1 in this expression, then we can get the magnetic dipole moment of an electron at first Bohr orbit, and which is equal to EH by 4 pi m. And this is known as Bohr Magneton. EH by 4 pi m, this term, that is magnetic dipole moment of an electron which is at first Bohr orbit, is known as Bohr Magneton. Now the term EH by 4 pi m, we can write this term as EH cross by 2m, because of it is denoted that H cross equal to H by 2 pi, and in terms of H cross we can write this term as EH cross by 2m, and this term EH by 4 pi m or EH cross by 2m is called Bohr Magneton, and which is magnetic dipole moment of an electron at first Bohr orbit. So what is the definition of magnetic Bohr Magneton? What is the definition of Bohr Magneton? The magnetic dipole moment of an electron moving in the first Bohr orbit is known as Bohr Magneton. So what is Bohr Magneton? Bohr Magneton is nothing but magnetic dipole moment of an electron at first Bohr orbit. So this is the definition of Bohr Magneton, and the expression of Bohr Magneton is EH by 4 pi m or EH cross by 2m. This is the expression of Bohr Magneton, and this is the definition of Bohr Magneton. The magnetic dipole moment of an electron moving in the first Bohr orbit is known as Bohr Magneton. This is the definition of Bohr Magneton. And now we are going to discuss about the value of Bohr Magneton and its unit. 1 Bohr Magneton equal to EH by 4 pi m, where E is the charge of an electron, H is the Planck's constant, 4 pi is a constant, and m is the mass of an electron. So if we use the value of this term, then we can easily get the value of Bohr Magneton. Now the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. That is why in place of E we can write this. And the value of Planck's constant is 6.62 times 10 to the power 34 joule second. That is why we write here in place of H, and 4 pi is a constant term, and the mass of electron is 9.1 times 10 to the power minus 31 kg. So if we calculate this, then we can easily get 9.27 times 10 to the power minus 24 ampere meter square. Ampere meter square is the unit of Bohr Magneton, and the value of Bohr Magneton is 9.27 times 10 to the power minus 24, and ampere meter square is the unit of Bohr Magneton in SI system. So this was the discussion today, that first of all the derivation of the expression of Bohr Magneton, and which is EH by 4 pi m or EH cross by 2m, where H cross equal to H by 2m. And the definition of Bohr Magneton is Bohr magneton is nothing but magnetic dipole moment of an electron at first Bohr orbit, and the value of Bohr magneton is 9.27 times 10 to the power minus 24 in SI system, and its unit in SI system is ampere meter square. So this was the discussion today. Thank you so much for watching this video.